Between 1969 and 1972, NASA brought back 842 pounds of moon rock. Today, no one knows where a third of it went. The Apollo program wasn't just a race to the moon. It was a race to prove that humans could survive there, work there, and bring back proof. That proof came in the form of lunar samples. Rocks, dust, regolith, material that hadn't been touched by Earth's atmosphere in 8 billion years. These weren't souvenirs, they were the crown jewels of planetary science, locked away in vaults, distributed to researchers worldwide under strict protocols. And then, sometime in the late 1970s, the accounting stopped adding up. July 20th, 1969. Neil Armstrong and Buzz Aldrin spent 2 hours and 31 minutes on the lunar surface. Most people remember the first steps. What they forget is the work. Armstrong and Aldrin collected samples methodically, filling bags, boxing materials, racing against their oxygen reserves. They gathered 47.5 pounds when they returned to Earth 4 days later. Those rocks became the most closely guarded scientific assets on the planet. But Armstrong and Aldrin weren't alone. 5 more Apollo missions landed. Apollo 12, 14, 15, 16, and 17 all touched down on the lunar surface. Each mission brought back more rocks, more dust, more questions answered. By the time Apollo 17 lifted off in December 1972, NASA had assembled what amounted to a geological library of another world, 842 pounds total. Distributed to 135 institutions across the globe, scientists in Germany, Japan, Sweden, and Australia all received pieces. The chain of custody seemed airtight. Here's what those institutions didn't know yet. They were about to lose track of some of the most valuable material ever collected by human hands. Not through theft, not through negligence exactly, through something far more mundane and far more damaging, bureaucratic drift. As the 1970s wore on, sample custody records became fragmented. Different agencies, different filing system, some institutions moved, others changed hands, and in that fog, samples began to vanish from the official record. 1978, a routine audit at NASA Johnson Space Center in Houston. Someone decided to actually count what was left. The math didn't work, not just a few grams off, not a clerical error. Entire samples, individual rock specimens collected during specific moonwalks had no documented location, no transfer record, no trail. They existed in photographs from the lunar surface. They existed in early distribution lists. But they didn't exist in any accessible vault or institution. The realization hit quietly, no alarms sounded, no press conference was called. What NASA faced was a crisis of transparency. They could either announce the loss immediately and face public scrutiny or quietly begin the work of reconstruction. They chose the latter. Over the next several years, NASA began contacting institutions, cross-referencing records, and attempting to rebuild the sample inventory from fragments of evidence. Some samples were found, many weren't. By the early 1980s, the scope of the problem became clearer. Approximately 280 to 300 pounds of Apollo samples had no verifiable location. That's roughly 1/3 of everything brought back from the moon. The question that haunted investigators was simple. Where did they go? Some theories emerged. Institutional staff turnover meant knowledge died with retiring scientists. Some samples were used in destructive testing, consumed by analysis, but the results weren't properly logged. A few specimens may have been lost to simple misplacement in storage facilities that predated modern tracking systems. But there was another possibility that investigators couldn't rule out. Some samples may have been deliberately removed. Apollo moon rocks had become extraordinarily valuable, not just scientifically, politically. The Soviet Union desperately wanted them. Foreign governments wanted them, and there was a growing black market for authenticated lunar material. A single gram of moon rock could fetch thousands of dollars on the underground market. Collectors would pay premium prices. The temptation was real. And security protocols at some institutions, particularly in the early 1970s, were far from Fort Knox standards. One case stands out. In 1998, a man named Thad Roberts, a former NASA intern, was arrested in connection with a scheme to steal moon rocks from the Johnson Space Center. He and co-conspirators had actually succeeded in taking specimens worth millions. They were caught. Roberts went to prison, but his case revealed a troubling truth. Security at the sample vault had gaps, large gaps. If one person had gotten in, how many others might have? But the Thad Roberts case was the exception that proved the rule. Most of the missing samples weren't stolen in any criminal sense. They were lost to time, to institutional failure, to the simple fact that NASA in the 1970s hadn't anticipated that tracking 842 pounds of moon rock across 135 different institutions would become exponentially harder with each passing year. The agency had solved the problem of reaching the moon. It hadn't solved the problem of keeping track of what it brought back. By the 1990s, NASA launched a systematic effort to recover and recatalog every single Apollo sample. It took years. Researchers contacted every institution that had ever received lunar material. They searched storage vaults. They reviewed old publications to identify which samples had been used in research. Slowly, methodically, they began to account for the missing pieces. Some samples turned up in unexpected places, filed under different names, mislabeled, or simply forgotten in basement storage. Today, NASA maintains what it believes is a complete or near-complete accounting of the Apollo samples. But the word believes matters here. Some samples remain unaccounted for, not lost forever perhaps, but their location is genuinely unknown. They exist in scientific literature. They exist in photographs. They may exist in a storage facility somewhere, filed under an outdated name or institution. They may have been destroyed in testing decades ago. With the results never properly documented, the uncertainty itself is the story. What makes this case remarkable isn't the conspiracy. There probably wasn't one at scale. It's the vulnerability it exposed. NASA had invested billions to reach the moon. It had engineered the most complex machines ever built. It had trained astronauts to survive in an environment that would kill an unprotected human in seconds. But when it came to managing the physical evidence of that achievement, the systems broke down. Bureaucracy failed where engineering succeeded. The missing moon rocks taught NASA a lesson that it continues to apply today. Every sample collected from space, whether from the moon, from asteroids, or from Mars in future missions, is now tracked with the kind of rigor usually reserved for nuclear weapons. Digital databases, chain of custody protocols, regular audits, redundant record keeping. The chaos of the 1970s and 1980 became the blueprint for preventing future loss. Some of those missing samples may still be found. Researchers occasionally contact NASA with discoveries: a moon rock identified in an old collection, a specimen discovered in a university storage room. Each recovery is cataloged, celebrated, and integrated back into the scientific record. But others will likely never be recovered. They've become part of space exploration history itself, not as triumph, but as a reminder that protecting discovery is just as critical as achieving it. The case of the missing moon rocks is ultimately a story about the gap between ambition and administration. NASA could send humans to another world, but it couldn't initially organize what those humans brought back. That gap has since been closed. The protocols are in place. The lesson was learned. But somewhere in a storage facility or an archive that no one has thought to check, a few pieces of the moon might still be waiting to be found. Subscribe to uncover more untold stories from the space age. Each week, we investigate the missions, the mysteries, and the human moments NASA didn't plan on.